and welcome everyone to my new lecture. Also, this is more kind of an educational lecture with diodes. You don't have to uh, copy this circuit to your Proteus. You can just watch the YouTube video clip here. So, all in practical applications, when you have to work for someone or something, I just want to show you what uh, in some cases you have to do. And if you saw a diode here and here with the motor or something like that, I just want to show you why is that done like that. So here, here is the circuit I made from this book I have, and here we have a motor inductive kickback protection. So I'm not gonna. A transistor is a very important electronic component, widely used, and it made a revolution in analog electronics. But I'm not gonna tell you how it is made or how does it work and so on. I'm just gonna talk you why do we put uh, diode. For example, this is a Schottky diode, but this is 1N5818 Schottky diode. I couldn't find that in the library. I think it doesn't have that specific device, so I took normal silicon diode 1N4001. So, well, let me just show you. If a current will go here when this input here is a 0, so it goes here, and it will turn off when here you have a plus 9 volts. This is a specific part of this is when the PNP you have to take this diode transistor. This is the device 2N2907. You have to put a diode in parallel because also motor is made out of coils. You saw in my last video, I hope you saw that we put a diode in parallel with the relay because they are inductive spikes, but also there are a lot of reverse voltage spikes. When you turn off this transistor, it shouldn't this motor shouldn't have no current here, but there are magnetic fields around this motor, and when you turn off, the magnetic field goes toward the motor, so the current can go uh, back to the transistor, and it can damage the transistor very well. But when you put a diode here, the diode reroutes or shoots the induced voltage to the opposite terminal of the motor, so that the current that would go to the PNP, it doesn't go to the this transistor. Sorry, it goes to the ground, and saves the that saves the transistor. So that's why if you ever saw a diode in parallel with a DC motor, this is a DC motor, you can uh, you can you know this is why we to protect the motor inductive kickback protection. That's the main that's the reason why we put a diodes. Usually Schottky diodes are good, and when I for example run the program or run this schematic, I have here, I don't know, 9 volts, and this is a pulsating this is a pulsating source. It has a period of 9 volts, then one period of 0 volts, and so on. So let me just let me just uh, okay. As you can see, when this is 0, or sorry, this is 9 volts, it doesn't. So if this is a 0 volts, the current will go towards this R1 power source, and the motor will spin uh, like this, and you see that there is a current going uh, here. Let me just from the beginning. Look, the current will go in this direction. Uh, so in the first part, it goes in this direction because there are inductive spikes. But with time, it's gonna stop that because the circuit is in a stable state. Now you see it goes a little bit toward like this. Uh, through in the reverse current just a few times, and now it doesn't go at all. So this is why we use diodes in parallel. Now the motor is in a stable situation. So this is a kind of practical way of making some motors. If you want a periodic motor that goes like this, there are a lot of situations when you need a motor go not always rotating fast, but in this kind of type. This is like a stepper motor. Okay, so I think you now know this is one more application of a diode, why we use it, and yeah, that would be it for this video, and see you in my next one. Goodbye.